talk about arithmetic sequences and partial sums. So this is section 9.2. So this is section 9.2 in the text. So hold on while we open up slides here. Yeah. So now we're on to arithmetic series, and partial sums. We have three major objectives: how to write and to recognize arithmetic sequences, how to find an nth partial sum of an arithmetic sequence, and how to use arithmetic sequences to model and solve real-life problems. Okay. So, oh wait, the T did not come out here. Not cool. So, we have certain properties of an arithmetic sequence. The first is that the difference between the consecutive terms is always the same. Okay. Meaning they're added or subtracted by the same number, and I can define it in terms of whatever number I want. Okay. So let's escape the PowerPoint slides. Open up this Animator here. And while I'm sitting here, fix this. That should be a T. Alright, so hold on while my which is up. There it is. Now, recall from last section, I showed you the difference between a series and a sequence. But in this situation, we're focusing mostly on the sequence. So for example, if I have the numbers 1, 2, 3, 4, 6, and 7, okay, what do I see? I see that each number increases by 1. Okay, right? 1 plus 1 equals 2. 2 plus 1 equals 3. 3 plus 1 equals 4. 4 plus 1 equals 5. 5 plus 1 equals 6. And of course 6 plus 1 is equal to 7. In this situation, the common difference, or what makes the sequence work, is the number 1. You see how the 1 is in common with this, this, that, and that. Okay. So in this case, the common difference Alright. So that's what we mean by an arithmetic sequence. That we can find some number that we add or subtract from it to get different numbers in the sequence. So now for the fancy definition of an arithmetic sequence. Okay. An arithmetic sequence, of course, has the terms. The definition of an is a sequence where the difference is the same. Right, so for any sequence, A1, A2, A3, A4, and so on. It's arithmetic when A2 minus A1 equals A3 minus A2 equals A4 minus A3 equals A sub n plus 1 minus A sub n, which is equal to the common difference d. So all of them are exactly the same. So now I want you to do some examples of how to determine if a sequence is arithmetic. So let's do that. Oops, we should put a box around that this way. And this is okay. There you go. There's your fancy box. All right. Oh. So we're going to determine the following are arithmetic sequences. Wow, that's a horrible looking arithmetic. So here are our examples. So we're going to determine the following are arithmetic sequences. Recall. Now, in the first situation here, for letter A, right, I can see that 5 minus 3 is 2, 7 minus 5 is 2, 9 minus 7 is equal to 2, 11 minus 9 is equal to 2, and, of course, lastly, 13 minus 11 is equal to 2. And because the difference between all of the numbers are exactly the same, we can say this is an arithmetic sequence. Okay. For example B, right, and we can already tell you it's not, then 8 minus 4 is equal to 4. right? You can see the difference is not the same. So this is not an arithmetic sequence. You can see the difference between the numbers here are clearly not the same. 2 is not 4. So this is not an arithmetic sequence. The last one what a solution on the new page. You already know. 5/4 minus 1/4 is minus 1 is 1/4. 3/2 minus 5/4 is also 1/4. Right? Change the denominator to 4. And you'll get 6/4. Right? Is also 1/4. And of course 2 7/4 is 1/4. And because all of these are exactly the same, we know it's an arithmetic sequence. Okay. So I will leave you and come right back.